So we'll go over how to prove that a quadrilateral is either a rectangle, rhombus, or square. So we talked about how to prove that a quadrilateral was a parallelogram before. Now we're getting a little bit more specific with rectangles, rhombuses, and squares. So remember, depending on what shape you want to prove, whether it's a rhombus, rectangle, or square, you have to show that the definition of that shape is true. So the definition of that shape is going to be the last reason for your proof. So as a reminder, we're talking about rhombuses, rectangles, and squares today, so these are the definitions. If we're trying to prove that a shape is a rhombus, we need to show there are 4 congruent sides. If we're trying to show that a shape is a rectangle, we need to show there's 4 right angles. And if it's a square, we will need to show 4 congruent sides and 4 right angles. So we'll do one example where we're trying to prove that a shape is a rhombus. So we're told that ABCD is a parallelogram, which is important, and that AC is perpendicular to BD, and we want to prove that the shape is a rhombus. So if it's a rhombus, we need to show that there are 4 congruent sides. That's what the definition of a rhombus was. So we start with our given. And since AC is perpendicular to BD, then we have a right angle. All of these angles, I'll put some numbers there, are going to be right angles. They're vertical, and one of them is 90, then they're all going to be 90. So I can say that angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4. And that is because of the definition of perpendicular and vertical angles together. So these are all going to have a right angle symbol. Now, since we know that the shape is a parallelogram, what we said before, then one of the properties of a parallelogram is that the diagonals bisect each other. So that means that from here to here would be congruent, and here to here is congruent. So we can write that. Let's put a letter in the middle where that point is so that we know what to call it. So BX is congruent to DX, and AX is congruent to CX. And that is a parallelogram property. We can use that because we know the shape is a parallelogram. They told us that in the beginning. So we can use all the parallelogram properties that we know. So based on that, I have 4 triangles that all have a right angle, so they all have a congruent angle, and they all have the same sets of sides. They all have a double and a single, a double and a single, a double and a single, a double and a single. So that means all 4 of those triangles are congruent to each other. So triangle BXA is congruent to triangle BXC is congruent to triangle DXC is congruent to triangle DXA. And they're all congruent by side angle side. SAS. So now that I have congruent triangles, I can use CPC2C to get congruent sides. So AB is congruent to CB, is congruent to CD, is congruent to AD. And that is by CPC-TC. So now we know, based on CPC-TC, that this side is the same as that side, is the same as this side, is the same as this side. They're all congruent. And the definition of a rhombus is that there are 4 congruent sides. So that means that I can say A, B, C, D is a rhombus because there are 4 congruent sides. And that is the definition of a rhombus. We showed that the definition was true, so that's why it has to be a rhombus by 4 congruent sides.